Okay, good morning. Welcome to
FunMath number 128.
FunMath number 128. So today we're still in section 6.2 of Art of Problem Solving's Algebra book, and we are doing ratio problems, and they brought up examples of clock problems. So the question we're going to look at today, and one of their example problems, one of their challenge problems was like this: at what time after 3 o'clock are the hands of a clock exactly on top of each other? And I meant, what's the first time? So, sorry, I didn't write what I meant. What's the first time after 3 o'clock that the hands of a clock are exactly on top of each other? Okay?
Yep.
Okay, so how are you going to approach a problem like this? What's the first thing you're going to think about?
Well, we can think about roughly what that time is.
Okay. And roughly speaking, what are you going to think about?
Well, the hour hand's going to move this way.
The hour hand's going to move down a little bit.
The minute hand's going to move much faster.
Yeah.
So, I think it's going to be between 3:15. 3:15 is less than our time, which is less than 3:20.
Okay. So the hour hand's going to move from, over the course of the next hour, the hour hand's going to move from the 3 to the 4. And the minute hand's going to come through and move all the way through that. So sometime between when the minute hand's pointing to the 3, which is 3:15, and when it's pointing to the 4, which is 3:20, at some point you're going to cross over the hour hand, right?
Yeah.
Okay, so let's write that up here so you have a little bit more room. 3:15 is less than t is less than 3:20. This little marker probably doesn't even show up on the camera. Sorry about that. Okay, so we think it's going to be between 3:15 and 3:20. That's our check. That's our check. So that if we get an answer, if we go through all the math and we get the answer is like 3:45, that's probably not right. Okay, so how do you want to approach solving the problem?
Well, the minute hand moves 6 degrees a minute.
How do you know that?
Because this distance right here is 30 degrees. These are, I think they're supposed to be all the same.
Yes, they are supposed to be all the same. Okay.
It takes the minute hand 5 minutes to move 30 degrees.
Okay, so all the way around the clock once is 360 degrees. That means these little pi wedges, and there's 12 of them, are 30 degrees. So the minute hand moves 30 degrees in 5 minutes, or 6 degrees a minute. Can you write that? Because your marker's a little better than mine.
Yeah. 6 degrees per minute.
For the minute hand.
Yeah. Now for the hour hand.
How fast does the hour hand
It takes
move?
an hour to move one of these pi wedges.
Okay, it takes an hour to move 30 degrees.
So that's a half a degree per minute.
Okay. Okay, so that's interesting. So the minute hand moves 6 degrees per minute. The hour hand moves half a degree per minute. All right, what's next?
Well, so for the time t, the minute hand starts at time 0 plus 6t.
Time 0, what do you mean by that?
0 degrees.
Oh, okay. So we're going to call the 12 0 degrees on the clock. Okay, so this is a 0 degree angle here. And at time t, what angle does the minute hand make?
The minute hand makes a 0 plus 6t.
Okay, so the minute hand is pretty easy. We say it starts up here at an angle of 0, and then when it moves, since it's moving 6 degrees per minute, it makes an angle of 6t. Okay, what about the hour hand here?
The hour hand, it starts at 90 degrees.
Okay, it
There's
starts
3
at
pi
90
wedges.
degrees, because it's pointing right over here, 3 pi wedges.
90 degrees plus 1/2 t.
Okay, so this is the angle that the minute hand makes at time t. This is the angle that the hour hand makes at time t after 3 o'clock. Okay, what can you tell me about those two angles? What are we trying to figure out?
We're trying to figure out what the angle is when they're on top of each other.
Okay, and what does that mean when the angles are on top of each other?
It means that there's no space between them.
Okay, means that there's no space between them. What else does it mean?
It also means that this angle is 360.
Well, that's true. How does that help you solve anything, though?
Doesn't really.
Yeah, it doesn't really. So let's ignore that. What are we trying to solve? What's the situation we're trying to solve?
I'm trying to solve for the first time after 3 o'clock when the minute hand and the hour hand are on top of each other.
Okay, great. We know that the angle that the minute hand makes is 0 plus 6t. We know the angle the hour hand makes is 90 degrees plus 1/2 t. So what can we say now?
Well, if we combine these, then we'll get 90 plus 1/2 t equals. Actually, no. What does it equal?
Why don't you draw the picture with my green marker of the time here on the clock that you're trying to solve for?
It's going to be something like, here's the minute hand.
Yeah, where's the hour hand going to be?
The hour hand's going to be right where the minute hand
Okay,
is.
draw me the angle that the minute hand makes at that time. Where's the angle that the minute hand makes?
The minute hand makes this angle.
Okay, what angle does the hour hand make?
It makes the exact same angle.
So, what does that tell you?
It tells us that 90 plus 1/2 t equals 60.
Okay, it tells us when the hands of the clock are on top of each other, it tells us that the angle the minute hand makes is the same as the angle the hour hand makes. Look at the picture. Here's the angle the minute hand makes. Here's the angle that the hour hand makes. Oh, those are the same angle. So 6t equals 90 degrees plus 1/2 t. Now, we got to separate the variables on one side. So what is 6t is 12t over 2, right?
Yeah,
What's 12t over 2 minus 1/2 t?
it's 11t.
11t over 2 equals 90, and t then equals 2 times 90, which is 180 over 11. Okay, now 180 over 11 equals, I'm gonna just tell you this equals about 16.36 minutes.
So,
Okay, so it's about 3:16. Okay, so solving the algebra here isn't as important as setting up the equations and knowing what they mean. So that's why I'm just skipping the algebra quickly. So a little bit after 3:15, the hands are on top of each other, and that's when the angles are the same. Okay, good job.